Hello, welcome to Calico Cloud. My name is Ludmila Huzenko. I'm DevOps team lead from Playtech. Today, I'm going to present you a topic for Kubernetes security, and in particular about securing connections between Kubernetes pods in your Kubernetes environments. In today's session, I'm going to talk about our journey with Calico towards GitOps network security management in Kubernetes. My team has been recently working on the project migrating our current Nomad-based environment to a new Kubernetes solution based on the EKS cluster. Part of the project was securing our pod-to-pod communication to substitute the current firewall approach for the Nomad. Today, I'm going to tell you about the journey on this way, the steps we take, and the automation we created for this solution. Also, about the lessons learned. The view expressed here is our personal experience, how to adopt network policies in your Kubernetes cluster, which means I'm not providing some universal scheme, but we want to share our experience, what went good, what went badly, to share our findings with community. First of all, I want to talk a little bit about the project itself, about its scope, about the requirements we need to apply to our environments. Also, I want to share the story how we migrate from Calico open source to Calico Cloud, why we decided to move to Calico Cloud, and what benefits it gave to us. Also, I would like to share our automation for existing Calico solution and also the lesson learned. I try to highlight some tips that might help you to adopt your own security solution in your Kubernetes cluster. So let's start with the project overview and the problems we addressed. I think these problems are common for all DevOps teams that enforce their own security solution in their Kubernetes cluster for the first time. From a security perspective, the Nomad cluster have dedicated nodes with specific load and that are secured by a predefined firewall network security scheme. In case of Kubernetes, in general case, the pods could be scheduled on any nodes. The pods can communicate to all other pods in the cluster. In this principle, create a clean backward compatible model where pods can be treated much like VMs from perspective of load balancing and services and port allocation, but from security perspective, it brings additional challenges to secure this kind of communication. Let me describe our system and security requirements for this project. We have a self-managed platform which provide infrastructure for multi-service applications with databases, monitoring, and logging solution on board. The complexity of network solution is dependent on the complexity of the ecosystem itself. From Kubernetes perspective, the basic setup for our environment is about 30-40 nodes and about more than 100 deployment and stateful set. It's not like a large setup for a Kubernetes cluster, but from security perspective, this is a challenge to understand all the communications between the components and to secure all the communications and to allow only those that are required. From product's perspective, we have additional security requirements to our products. So we have 3 types of access. First one is the internal endpoints that are accessed only from VPNs. And the second one is the endpoints that are publicly accessed. And the third one are the endpoints with privileged access. This means that they are publicly exposed, but they have certain whitelisted subnets. From security perspective, that brings additional complexity that we need special security rules for all of these access types and special mediators like load balancers, gateways, which provide access to certain types of the endpoints. Also, from a security team, we had additional requirements. First is that we need to provide such port-to-port communication that allow only the required access and deny all other possible connections. And on the other hand, we need to provide MTLS between all the services and all the pods. Shortly, I will describe why we chose Calico. First is that it is market leader and production-ready solution. The second one, it is the lightweight. So it means a lot when we are talking about the daemon sets, because daemon sets are deployed on each node and consume some resources on each of your Kubernetes nodes. Also, the important thing was that it supports a broad range of platforms, both on-prem and cloud solutions, as the second stage of our project is to provide the same solution to our on-prem Kubernetes environment. And the last but not least is that the Calico OSS is an open source solution. Although I have already given a spoiler that we are not using Calico open source solution and we are using Calico Cloud, but it's still an advantage of Calico OSS product. So let's go with the story why we moved from Calico open source to Calico Cloud. So what is the story behind the spoiler? We started with the installation of Calico open source into our Kubernetes environment. We read the documentation, we created POC, and then started to create manually all the tools and the rules for Calico policies. But there is always tricky things in every technology that you need to know before implementation. And in case of the network solution, in case of network policy, this means that sometimes you can block the traffic. For example, from my own personal experience, if you put the path policy in improper place, you can block a large amount of your traffic and change the policy order. Considering that that was environment under construction, meaning that a few DevOps engineers were working on it and providing some solutions, you never know what could go wrong there. And if something is broken, you need to debug this issue. In general, there could be two kinds of issues, Calico-related and non-Calico-related issues. If we look at this picture, this is the very simple case for providing certain service for a user. The request is going through network load balancer, ingress ports, application service, and the application deployment. So what could go wrong there? First thing is the application configuration on the configuration of the Kubernetes service itself. Then in our case, it was issues with Istio configuration. Also, we made some limitations and issues with the network load balancers. When we finish with checking non-Calico related issues, we're starting to check Calico policies. This means that you need to check the existing policies in your code and compare them to the policies inside your environment. Because you never know who added another policy to the live environment without adding it to code. If you can't find any configuration issues with Calico policies, then you try to debug the Calico policy itself and check if any traffic is blocked. And in case when we have like 3 pods of ingress deployments and 3 pods of application deployments that could be located on different nodes, in this case, you will need to debug connections between 6 nodes in any order. And to simplify this debugging, we decided to downgrade the nodes, and then we had at least one-to-one connection that we need to debug. And the tools that you can use with Calico open source are IP tables and TCP down, which are not really hands-on tools to use on a daily basis. Considering all these steps, we decided that we need to some better solution because we met this limitation on Calico open source. So what were the main pitfalls of Calico open source usage? First of all, it was a lack of existing policies visibility, which means on one hand is that we couldn't see the actual state of the policy on the environment. So some of them were in code, but you don't know if the same ones were on environment. And the second one is we have a rather complex network security scheme, and it's really hard to keep it in mind and understand how certain policy will affect your traffic. The second was the lack of network observability. This means that you don't know the actual state of your network traffic. Is it blocked? What part of it is blocked? Is this issue related really to the Calico policies, or maybe something else is not working? Also, the limitation was the lack of debugging tools because personally I don't like to work a lot with IP tables and TCP dumps, and considering the scenario above, it's a tricky thing. So I would like to share the features of Calico Cloud we used most of time to create our network solution. Because when you decide to migrate from open source to paid solution, you are scrolling these comparison tables trying to understand if paid solution can solve your issues with the open source one. In most cases, you need to create POC to understand this. Maybe my following slides will answer your questions about the Calico Cloud features that you can use for creating your solution. Let's move to Calico Cloud. This is a policy board of our Calico Cloud solution that includes 7 tiers and a lot of rules. Let me explain a few terms from Calico concept to be on the same page. In Calico, you have endpoints. This is the destination point of your traffic. Basically, these are the pods grouped by certain labels in certain namespaces. For these endpoints, you are creating the rules that allow denied traffic from other namespaces and from the pods also grouped by namespaces and labels. The rules are grouped with tiers that you can see here, and when the traffic flow is coming to your cluster, it is coming to the first tier, to the left one, then going through the rules. And if you create the path policy, then it's going to the next tiers that have the corresponding endpoints. As you can see, the scheme is not that easy. So when you have the visual representation of it, you can just check it and understand how the traffic is going through each of the tiers. Also, you can check here is if some of your rules have 0 endpoints. That means that this rule is improperly configured, or maybe some of your applications are broken and the pods disappeared from your environment. Also, here you can configure your own policy, and you can configure your own tiers, changing the orders, and check if some traffic is blocked by a certain policy. Let's continue with service graph. This is the service graph that we also are using with the Calico Cloud, and it is handy when you want to understand the communication between your pods and namespaces. Here you can tag the connections between the pods or the namespaces, and if the communication is allowed, it is blue line. If it is blocked, it is red line. So you can have the overview of the connection map of your environment. Also, there is a nice table where you can check the deny and allow logs. And there is essential information about the time, source namespaces, labels, and destination entities as well. Also, there is a useful feature we are using is the packet capturing. This means that you can run kind of TCP dump for certain pod or for certain namespace, and download it from here. If you want to do it by yourself, you would need to run TCP dump on the respected nodes and then download from each of it. The last but not least feature is Kibana dashboard that we are using on a daily basis if we implement some new policies. It provides built-in Kibana dashboards. We are using mostly the flow logs dashboard. Here we can see the overall status of the environment and the traffic history. If something happening, you can check here if the rate of your blocked packets increased. Also, you can provide some filtering here and check the required traffic. And also the important things here is that you can monitor the state policy traffic. I mentioned earlier that it is a useful feature when you can create the network policy, then apply it in as staged one and monitor how it affects your traffic. And in Kibana, you can apply additional filtering and find out the traffic affected by this policy. Also, one of the useful feature here is the DNS dashboard, where you can aggregate the external connection of your cluster. So you can get the list of domains your cluster is connected to and use it in your egress policy configuration in Calico and in Easter as well. So these were the features that helped us a lot to create our network security solution in Calico Cloud. The next step was automation. In our project, we aim to follow GitOps approach for all our configuration, and we decided also to put our network policies into the code. Firstly, we had all these policies in Calico Cloud UI, and the simplest way was to download those policies from the UI and keep them in our repository. We grouped them by tiers and applied them to the environment with Argo CD. It was already a policy in a code solution. And if we wanted to add some new policies, we just committed it to code and applied with Argo CD. Also, the advantage of this first step was that policies were applied by Argo CD, so we could always check there what policies are already applied to the environment. But disadvantages was that a lot of things were hard-coded there. We have environment-specific naming for certain namespaces and environment-specific subset of applications. And that's why we couldn't just apply the same network policy code to another environment. So we decided to create our own Helm chart and play the network policy manifest to be able to apply them for all environments. So we created a set of application network policies that could be applied for all the environments, provided them the environment-specific variables. In this case, we got the solution that could be scaled to all our environments that have central management of network sets and environment-specific variables. And it was environment agnostic and could be applied both to our single environment and to multi-environments. But still, we have the disadvantage that in case we need to find all the policies that could be related to certain traffic, we had to look for the policies in different files and in different folders, because the traffic is going through different tiers and through different policies. Also, when you have a lot of manifests, you don't really go with the don't repeat yourself principle, as a lot of things are repeated from file to file. So we decided to implement another solution where you have description of all of your rules in a single file. And you have 3 files for templating: templates for tier, template for policy, template for network set. In this case, in this single file, you can see all the tiers and the policies you have on environment. And you can easily see what is implemented from the code base. The disadvantage of this solution is that you need to create this structure based on your environment and on your application. It requires additional work, but this is one-time work. This file could be applied to any of your environments, and if you have the same application set on each of it. So let's continue with the lessons learned. To summarize the key points on how to implement network security in Kubernetes environment, I have collected few tips that might help you in securing your Kubernetes environment. First is simplify your solution with proper Kubernetes setup. Maybe it is more applicable to those of you who are currently migrating your solution to Kubernetes. But it's never late to refactor your code and make it more simple. By simplicity here, I mean network simplicity, and let me clarify what I mean. So one of the way to simplify your solution might be grouping your application into a certain namespace. This application should do the same things and provide some services to other namespaces. For example, you can have namespace for your login applications, for your monitoring application, ingress, and your business application itself. In this case, you can start your security scheme with securing the connection between the namespaces, enabling communication between all the ports inside the namespace. It's not basically the best secure solution, but it could be the first step to introduce your solution in your environment. The second entity that is used in Calico policies is labels. When you are migrating your application to the Kubernetes, you should think about correct labeling of your application. Certain service requires specific network security rule. You should provide it with additional label. For example, you have My App application, which include backend pods and admin pods. Both of them are connecting to database, but only My App admin is exposed to be available to the admin user. In this case, you can create the security policy for both of your services based on the common template app is equal to my app to access the database, but you should also have the additional labeling to provide access to the admin pod itself. The third thing I wanted to highlight is that when we are talking about automation, you shouldn't have any hard-coded values in it. And the network sets are a good way to use for your VPN subnets, whitelisting lists, and blacklisting lists to be applied to your environment. So let's continue with the second lesson we learned. This is about the horizontal and vertical rules ordering of your network scheme. By horizontal ordering, I mean the order of your tiers. And by vertical ordering, I mean the ordering of the rules inside your single tier. Let me start from the vertical ordering. Your tier is like a sieve. So when you put there some rules with specific endpoints, all the traffic corresponding to these endpoints is going to be checked through this tier. If there are the rules allowing or blocking rules for a certain part of the traffic, it will be processed accordingly. But the left part of the traffic is going to be blocked by implicit default deny, or you should explicitly create path policies to move it further to the following tiers. So for the tier configuration, you have two options. One of them is when you create one rule for the certain scope of your endpoint, at least in scope of the single tier. So you create all allow and block rules in the same rule scope, and you provide a path policy inside the same rule. In this case, the left traffic is going to be passed to the following tiers. Or the second option is when you create all your allow and blocking rule policies in any order as you want, but the last rule should include all the endpoints above and provide the path policy for them to be processed further. And from a horizontal perspective, there are three types of tiers. First one includes global network security rules and mandatory path policy at the end. This type of tier, this is the first tier on this picture, could be used for such kind of policies that are applied to the whole cluster. That could be access from certain VPN subnets, or applying some block listing to your environment, or maybe implementing some whole cluster solution like monitoring or logging, and you put all these rules to the tiers that are located left. The second type of tier is related to a large group of your endpoints. In my example above, this could be the case when you want to allow all the connections inside your namespace. In this case, the configuration of your tier should be following. You create rules for the large group of endpoints, and then you should create the path policy for all the endpoints that you mentioned above. And the third type of tiers is related to some specific access. So this is some point-to-point policies, some connection between applications. Or in the examples I provided, this is the access to the admin service, access between certain namespaces. From configuration perspective, this tier has access and block rules, but it could have or could have not the path policy, because on this stage you may already create all the rules for a certain application and you don't want to move the left traffic further to following tiers. In this case, you just don't create any path policy and all the traffic will be blocked by implicit deny at the end of the tier. But in case you create the path policies for the third type of tier, you will have to have the another tier with default deny policy. In case you go on with paradigm to block all the connection unless they're explicitly allowed. Finally, I want to share our experience regarding introducing deny all policies. First of all, this is the final stage of configuring your network security. With Calico Cloud, you are able to create stage deny all policy and then monitor all the traffic that is coming through this policy if you don't want to block this traffic in future. Also, for deny rules, you have three options. First, you may introduce deny all policies for certain namespace. So you can work step by step for introducing deny all and blocking all the traffic in the cluster except those that is already allowed. The second option is that you can use deny all with exception. It is recommended that you may create exceptions for such namespaces like Kubernetes system or Calico system to be sure that are not blocking traffic inside it. And if you're absolutely sure that all the rules are configured and that you don't want to add any others, you can just apply the deny all policy to a cluster without any exception. To wrap it up, the final lesson learned is about our general impression about the essentials you need to consider while introducing your network solution. The first thing you need to consider is observability. When you have a complex solution with sophisticated network scheme, you will surely do the implementation of your network solution step by step. You will need to add some code, test it, debug it, and add another part of the code. And in this case, you surely don't want to spend a lot of time on debugging phase. The second thing is the clarity and consistency. Before starting your implementation, it's always good to have a final picture of your network scheme and a plan how you are implementing it step by step. For example, you can take advantage of my previous suggestion and group your application into certain namespaces, create the picture of your network policies, create the tiers, and create the plan how to implement all of them. Also, a very important thing is automation. And when you are doing automation, you should also think not about your current environment, but about all the cases you need to cover with this solution. Maybe you have different types of environments, maybe you have multi-environments. All this code should be easily integrated to each of them. I hope you learned something useful for enabling your own security solution in your Kubernetes cluster. Thank you for coming to the session. It was a pleasure to be here.
Cloud-native applications can't be secured with the traditional security tools. You need a more active and granular level of security. Calico Cloud is an active cloud-native application protection platform that detects, prevents, and mitigates breaches in cloud-native applications. Let's look at how to secure your cloud-native environment at build time with Calico's container security. At build time, we want to make sure that images that the development team provides are clean and without major vulnerabilities or misconfigurations. All image registries are auto-populated and continuously scanned by Calico's scanning engine. I can also manually add new registries. It's very easy for me to see the results of the last scan from the scan results page. Pass-fail is color-coded with specific scores. Details about each vulnerability that impacts each image are available on the right side. I can control which images can be displayed to my environment using admission control policies. I am only allowing images with pass or worn scan results. I've also enforced an upper limit for the age of a scan result. Now, if any application developer attempts to deploy an image that doesn't pass the security criteria, it will automatically be blocked. Once you have the admission policies in place, you may come across a situation where the application developer is telling you that a particular vulnerability does not impact their code and the way in which they are using the affected library. In this case, you need to create an exception. Calico Cloud offers a number of options to scope the exception to a specific image version, any version of this image, or any image. In addition to scanning and assessment of images, I must ensure the Kubernetes environment is also secure and does not have any misconfigurations. Calico helps you continuously assess your Kubernetes configuration using compliance reports that assess your configuration against CIS benchmarks. I scheduled my CIS benchmark report to run every 24 hours. The number of nodes passing or failing the CIS benchmark tests is color-coded. And here are the top failed tests. I can also download the full report to get more insight on each test and how to mitigate its risk.